This presentation is an overview of some of the concepts on the guiding principle of understanding and managing variation. I'll cover 5 topics in this presentation. First, an overview of the simulation exercise Dr. Deming used, the red bead factory. He started teaching this exercise to the Japanese in the 1940s and 50s and on through until he passed away in 1993. Second, some ideas about why understanding variation is important. Third, some ideas about why we currently don't have a lot of people that understand or seem to understand this important principle. Fourth, some of the basic concepts behind the principle. And fifth, learning how to react when we don't have data. In each of his 4-day seminars, Dr. Deming used the red bead factory exercise to teach a number of important concepts, including but not limited to understanding variation. In the 4-day seminars, he would ask for willing workers to come up and work in the bead factory. He played the role of the foreman. He also used inspectors and an inspector general and a recorder. If you want to view the video of some of these actual 4-day seminar demonstrations, you can go to the link on the top of the page. He also incorporated the use of posters by the foreman, and you can see some of the posters that the foreman would show to the workers to exhort them to do better. So in this exercise, Dr. Deming would mimic some of the prevailing style of management that we see in most of Western management, and he used the bead factory to demonstrate this. In this next slide, I'm going to do a quick overview of typically what would happen in the 4-day seminar. You see the names of the 6 willing workers that are listed here. He would explain how the beads were produced, the idea that the factory was in business to make white beads, not red beads, and that any day may be the last for the workers. It was entirely up to them whether they kept their jobs. So he exhorted them to do their best and to produce white beads, 50 per lot, each time that the workers dipped into the bin. Mary stepped forward and produced the first batch, and she got 9. And Dr. Deming reminded her that 9 defects was not good. We needed to have all of the beads, white beads, so he exhorted her to do better the next time. Bob came up next, and he produced 6, and the manager, or Dr. Deming as the foreman, assumed that Bob was listening and understood, based on Mary's production, that he needed to do better. So the foreman thought that it was because of his management that Bob did better. Sally came up next, and she produced 12. Dr. Deming was, as the foreman, was not happy about this and wondered why Sally, perhaps she wasn't paying attention. Didn't she understand that they were in the business of producing white beads, not red beads? And she was exhorted to do better the next day. Fred came up and produced 11, 1 less than Sally. He too was exhorted to try harder. If Bob could do 6, the rest of them could do 6. Harry came up next, and Harry did even worse than Sally. Harry did 14. So the foreman was quite upset with this and reminded Harry that he could be put on probation and that any day could be his last. Finally, Peggy came up, and Peggy did the best of the day. She got 4. And so the foreman totaled, or the recorder totaled for the day, and the foreman took a look at what the cumulative average and had a talk with each of the employees and told them that this was not good enough. They would have to do better. They were in the business of producing white beads, not red beads. He put Harry on probation. He had been warned that any day could be his last. He was clearly the worst worker of the lot. And Peggy was rewarded with being the worker of the day. She was given an extra pay and also a parking spot closer to the door. And everyone was asked that if Peggy could do 4, the rest of them could do 4. And he was extolled the workers to do better on day 2. Mary came forward on day 2, and she did even worse than the day before. And the foreman couldn't understand this, thought that perhaps she wasn't paying attention to business, and perhaps she wasn't interested in continuing on with the factory. He reminded everyone that any day could be their last. Bob came forward and he also produced 11. So here you had two workers that had gone from lower numbers on the first day to worse numbers the second day, and the foreman just couldn't understand it. So Sally came up. He reminded her that she certainly couldn't do worse than she did on day one, and sure enough, she produced better numbers. So the foreman thought that this was because he had a tough talk with Sally and she had seen the light and she was now going to produce better results. Fred came up and he was a little bit better, but not by much. Harry came up. He was reminded that he was on probation. He had to do better this day, and he did do better. He did 8, and the foreman thought that, again, this was because of his management approach that things had gotten better. And Peggy came up, the worker of the day, day 1, and she was one of the worst workers of the day. And the foreman thought that perhaps the pay had gone to her head and that she wasn't paying attention to things. They did a total for the day. It was worse than it was the day before. So again, the foreman had to have a conversation with the workers that they were going the wrong way. They needed to produce less defects, and he reminded them to take a look at the posters. He also let them know that management had come up with a great idea. They were going to make day 3 zero defects day, and Peggy was going to no longer be employee of the day. This role was now going to be Sally's role, and she was going to be employee of the day. And again, zero defects day. The foreman pointed out that management had come up with a great idea. Every employee was going to sign a pledge that they would hereafter produce no defects, and there was going to be a band. The company president was going to make a speech, and everything would be better on day 3 because it was zero defects day. So Mary came forward, and she produced a little bit better. It wasn't zero defects, but it was better. So management or the foreman thought that perhaps things were going to be shaping up. Bob came up, and he did about the same as he did yesterday. And the foreman couldn't understand it. What was wrong with zero defects day? Why weren't things getting better? And he exhorted the workers to do better, reminding them that every day could be their last. Here was Sally. She was now employee of the day, and she came up, and she did even better. And the foreman felt that this was because of his management approach, and reminded everyone that if Sally could do 5, everyone could do 5, and that should be the goal from here on, although the goal should be 0 because it was zero defects day. So Fred came forward, and before Fred could have his mark assigned, he dipped twice into the batch, and the foreman reminded him that he wasn't following procedures, so he was fired for trying to fudge the system. Dr. Deming asked for another volunteer. Someone named Al came forward to replace Fred. He was reminded that the job of the bead factory was to produce white beads, and so Al came forward, and he produced even worse than Fred did. And Dr. Deming couldn't understand it. Didn't Al understand that he too had signed a pledge to produce zero defects? So Harry came forward. He was on probation, but he had done better than the previous day, and on this day it was not much better, but somewhat better. Certainly wasn't as bad as his first day. And then finally Peggy, she was clearly going the wrong way. She was employee of the day, day 1, and now she was the worst employee nearly the worst employee of the day. So the total for the day, zero defects day, did not produce any better results. You can see the cumulative average. And again, the foreman talked to the workers and reminded them that if they weren't able to do better, that the factory was going to be closed and that they would no longer have jobs. So he exhorted them to do better. Mary came forward. We now had a new person who was on probation. This was going to be Al, so Al was now on probation. And we were going to have Mary come forward, and she did about the same that she did yesterday. Perhaps this wasn't going to be good enough to keep the factory open. Bob came forward. He had 11 the day before. He did better. He had 9. Perhaps things were shaping up. The foreman couldn't be sure. Here was Sally, the employee of the day from yesterday, and she did about the same today. So again, he exhorted all the workers that their new goals should be 5. If Sally could do 5, everyone should be able to do 5. So Al was on probation. He had the worst pour of the lot yesterday, and he came forward with 9. And so the foreman thought that this was because he had a tough talk with Al, had him on probation. Perhaps he would no longer be on probation. It depended upon what the total production for the workers were that day. and we had Harry come up, and Harry did worse than he did the day before, and the foreman couldn't understand it, why he was now doing worse. So Peggy came up. Clearly she was employee of the day, but things had gone the wrong way, and she still had produced high numbers, the worst number of the day, and the foreman just couldn't understand it. And even though that the numbers as a total were better, they thought they were going to have close the factory down. But management had a brilliant idea to take totals and see who had the best records of all of the workers, and they were going to keep the factory open with the best workers from the past. So they identified those with the highest numbers. And clearly Al was not going to be able to stay on board, even though he was only there for 2 days. He clearly had the worst numbers, so Al was going to be replaced. And Harry, second worst numbers. He was no longer going to be working at the bead factory. And then finally Peggy, she started off as employee of the day, and she was clearly not going to make the cut. So these 3 workers were dismissed. So they started day 5 with a brilliant idea for management to keep the factory open with the best workers from the past. Mary came forward, and she had the worst day of all that she'd ever had, 16 defects, and Dr. Deming, as the foreman, couldn't understand it. Bob came forward, slightly better than the day before, but still not down to where it needed to be. And then Sally came forward with 8. So she had gone from employee of the day with 5 to now 8. She was clearly going the wrong way. These 3 workers had to work a double shift, so each of the workers did again. Again, Mary, not much better with 11, and Bob, even worse with 10, and then finally Sally with 9. So they totaled up the day, and they found that they weren't going to be able to keep the factory open, so they closed the factory down, and all of the workers were dismissed, including the foreman. After the bead factory demonstration, Dr. Deming always illustrated the fallacy of the foreman's actions, demonstrating that the number of defects shows random variation only. He always plotted the data from the bead factory. This is a graph from Dr. Deming's 1986 book, Out of the Crisis, from one of his demonstrations in Nashville. Mark Graben has a recorded webinar where he explains some of these concepts as well. You can view and hear the recording by going to the link provided. Mark also explains the fallacy of the prevailing style of management when managers praise people or individuals when they do well, and then kick butt when their performance deteriorates. Over time, the manager comes to believe that the results are due to his or her management and to the response of the workers. In reality, this is not true. The results come primarily from the system, and the manager is reacting inappropriately to random variation. The red bead demonstration includes lessons about understanding and managing variation, but also other parts of what Dr. Deming called the system of profound knowledge, described in his 1993 book, The New Economics. He always shared this letter that was sent to him by a woman named Anne, one of the willing workers, from one of his 4-day seminars. Let's read it together. Here are some thoughts from someone named Anne who served as one of the willing workers. When I was a willing worker on the red beads, I learned more than statistical theory. I knew that the system would not allow me to meet the goal, but I felt that I could. I wished to. I tried so hard. I felt responsibility. Others depended on me. My logic and emotions conflicted, and I was frustrated. Logic said that there was no way to succeed. Emotion said that I could by trying. After it was over, I thought about my own work situation. How often are people in a situation that they cannot govern, but wish to do their best? And people do their best. And after a while, what happens to their drive, their care, their desire? For some, they become turned off, tuned out. Fortunately, there are many that only need the opportunity and methods to contribute with. On this slide and the next few slides, I want to elaborate on a point Dr. Deming made, that the most important application of the principles of understanding variation is in the management of people. In the diagram on the left, we see the distribution of the output of some group, any group on any attribute. Some are above average and some are below average. The differences mean nothing. They are there by random variation. I've seen some people divide up the distribution into parts and label the people in the parts of the distribution as different. I think this is wrong. Another example of tampering. The person who is outside the distribution could be outside on the good side or the not so good side. Either way, they deserve special study and perhaps help. Dr. Deming had a great way to explain this through a simple algebraic equation. He said, let x equal the individual and y the system. So y times x is the interaction between the individual and the system. There's some outcome that we're interested in. Let's say it's 8 mistakes, or perhaps $8 million in revenue, and we need to solve the equation for x. Unfortunately, there are two unknowns and only one equation. He always said, Johnny in the 6th grade knows that no one can solve this equation for x, yet people that use the merit system think they are solving for x. They ignore the other term, the yx, which is predominant. These next several slides come from Mr. Hiro Hackabord, who worked closely with Dr. Deming over many years. I like his elaboration on this point Dr. Deming made about attribution of the effects on the individual and the interaction of the system. Hiro describes 3 worlds. World 1 is shown here, where performance P comes entirely from the individual, and there is no interaction with any system whatsoever. So the performance of the individual is independent of the system. In this situation, pay for performance, ranking, and rating might make sense. Performance, the P, can be increased by focusing on the individual. Over-reliance on extrinsic motivation, however, is another problem. If such a world exists for the individual focusing on improvement, you'd have a different problem related to reliance on extrinsic motivation, which destroys intrinsic motivation. But that's a discussion under another topic at a different presentation. So the question is, can you think of a situation, any situation, where the performance comes entirely from the individual and there is absolutely no interaction with any system? I don't think this world exists. Some have told me that sporting events or athletics might be an example, where one person comes in first, another second, and so on. Yes, that's true, but in athletics and games there are rules. Those are part of the system, and so is the environment. For instance, the weather, the conditions, the fans, and even the officiating. So I don't think that you'll see world number 1 in our reality. So we think about world 2, which is represented by the individual circle completely consumed by the system circle. In this situation, the individual is totally subjected to the system. The performance of the individual is totally unknown. All of the outcomes on the performance are attributable only to the system, and the performance is improved only focusing on the system. In this situation, ranking, rating, and even control charts are not going to identify any individual effects. So the question is, does this world exist? The only example I can think of is the one I just described, which is the demonstration of the red bead factory that Dr. Deming used in his 4-day seminars. He controlled everything. He was the foreman. The performance came entirely from the system. There was no contribution from any of the willing workers. He got the same results with any set of willing workers, no matter what city he gave the seminar. It's a great demonstration of a number of concepts, but I don't think there's a real-life example of world number 2. So we are left with world number 3, where there is this overlap between the individual and the system. Sometimes the amount of overlap is huge, and sometimes it's a little. The performance of the individual in these situations cannot be separated from the system. It is unknown, just like that algebraic equation. The performance is improved by focusing on the system and individual interaction. Ranking of individuals makes no sense in this world. Control chart of valid numbers of performance can identify special causes that could be due to the individual. Here's an important point. The more that you know about how to react when you have data, the better you'll be prepared to react when you don't have data. So, as I said, I believe world 3 is the world in which we live. It applies in social systems like education, business, and organizations. All decisions regarding people have to be taken into account with the system or systems in view. Most of the outcomes are attributable to the interaction of the individual and the system. It is true that sometimes the outcomes are attributable to the individual. It's true that people have a free will. We see examples of not understanding variation and how to react to variation every day. For instance, a patient in a hospital receives the wrong dose of medication, or the wrong medication, or a wrong site surgery, or the wrong patient. What's the typical reaction? Typically, we go find out who did this. Then we want to take punitive action, perhaps fire the person, or perhaps jail. This is true. I've seen these examples. I bet you have too. It's the wrong way to proceed. How does this knowledge about variation react when you don't have data? This is where the most important applications of World 3 are. We also know that systems drive behaviors. Here are some examples of some behaviors you might see in any sort of a workplace, in any situation. When people focus on the short term, if they think that there's a linear cause and effect relationship. People focus on themselves. They focus on being right. People start and react to gossip. People focus on winning, focus on looking good. People distort the numbers. People focus on getting better results. People are uncooperative or appear to be uncooperative. People are impatient. People focus only on their business unit. They focus on the one root cause as if it really existed. People do firefighting. They focus on what's wrong, not what's right. They focus on the parts of the organization, not the whole. There's shame and blame in the workplace. People also resort to heroic efforts. They end up blaming people and blaming each other. They hide the real data. People giving orders. People asking who as opposed to why. The tendency to overuse email when people could be talking face to face. In each of these situations, you see these behaviors. The first question you should ask yourself is, what is the system? What is the system that could be causing the behaviors, not the individual? Management's job is to determine the culture that they want in their organization. A useful way to think about culture is the sum of behaviors that are exhibited in an organization. So we know that systems drive behaviors. You need to decide the kind of culture you want, decide the kind of behaviors that represent this culture, and then work on the systems that drive those behaviors. So in order to learn how to understand reacting to variation when we don't have data, it helps to learn from applications when we do have data. Here's a real-life example of people trying to understand variation and perhaps some of their miscues. So a team is trying to improve their turnaround time for a process. They plotted the actual times on the left, which is the red line. So give them credit. The first step is to plot the data in a run chart, and that's a good chart. But they have the goal, which is the purple line. And where there are deviations from the goal, they ask people why. You can see the explanations written on the chart. So why is this wrong? The problem is this could just be random variation. They would need to calculate the control limits to be sure. Whenever you're asking people to explain random variation, just like the foreman asking people to explain why they were producing those defects, they are creating non-value work. It's actually muda. Here's another example. I saw this report in an organization where they were looking at the expenses per case for different rehabilitation and physical therapy departments. Well, it's tough to see what's important here, so the boss helps people out by circling the highest number. So they look at the column, and they found that the $130.15 per case is the highest number. So why did they circle that one? Well, some number had to be the highest and some number had to be the lowest. So they thought by circling the highest and asking that manager to explain why his costs were the highest was the right way to proceed. In actuality, if you plotted the data, you would see that they too form a random distribution. And you can see, just like with the bead factory, that these data appear to be all random, and there's no rational reason for anyone to ask any of these individual results why they're different. Here's some additional thoughts and implications on this example. When you look closer at the departments, I noticed that some were labeled as rehab and some were sports medicine. Perhaps this wasn't correct, and maybe they needed to put the sports medicine separately on a different chart. Perhaps this wasn't a homogeneous group. Whenever the boss asks people to explain why number is higher and another is lower, it's not rational. It, again, causes all sorts of extra work. And also frustration on the part of the person who has to chase down the answers, for which there is no rational answer. Dr. Deming said, when faced with this kind of faced with this kind of fear, people will either improve the system, they'll distort the system, or they'll distort the numbers. Whenever there's fear, you're going to get wrong numbers. How many people know how to improve the system? It's much easier to distort the system or to distort the numbers. Studying improving the system is hard work. So if these departments do indeed comprise a system, which means working together toward a common aim, that's a hard path to take. It's much easier to line up the departments and hold them each accountable for better numbers, even though it's the wrong way to proceed. We always have to remember to couple our subject matter knowledge with our understanding of variation, so the two go hand in hand. Here's a number of reasons why I've thought that perhaps we do not see many people understanding these concepts, even though Dr. Deming taught this for years and years. First of all, the Toyota managers that learned about this in the 40s, 50s, and 60s had a deep understanding about handle variation over the years. They developed systems and tools to manage it, but those who have been copying Toyota never developed this fundamental understanding of variation. They're just copying what people do on the surface. Another reason is perhaps it wasn't fully understood, especially as it relates to the management of people, so it wasn't taught. Another idea is perhaps this has been placed in some container. I've had some people think of this as being a Six Sigma thing and separated from Lean, which I don't think is true. Another reason could be the teachers never learned it, and this could be an example of Rule 4 of the funnel, which is going to be a demonstration we'll see shortly on one of the slides. And finally, I think that the way that we think trips us up. I highly recommend a book by Daniel Kahneman called Thinking Fast and Slow, which describes some of the fallacies of thinking in what he calls System 1 and System 2, and how System 1, using intuition, will lead us astray, and it's not wired to understand things like understanding variation. So that requires work with what he calls System 2. I have a reference for that book at the end of this presentation. So let me summarize to this point the points that I've covered thus far. I've explained how Dr. Deming helped people to understand the important concepts of variation using the bead factory demonstration. I've covered some of the reasons why understanding and managing variation is important, in particular in the times when we don't have data. And then thirdly, what I just showed was some examples or some possible reasons why most people these days may not be aware of these important concepts. In the next few slides, I'm going to cover some of the key concepts related to understanding variation. First of all, this is foundational knowledge that was discovered by Walter Schuhart before Dr. Deming and then expounded by Dr. Deming and others. This knowledge was introduced to the Japanese managers and engineers starting in the late 1940s and then on in the 50s and 60s. Some companies, like Toyota, use this knowledge to build their improvement systems, and the thinking is deeply embedded there. This is one of the whys behind the what. Therefore, I think it's a guiding principle. This is not a Six Sigma thing, although many people have mistakenly put this in that container. And another important point, this is not the kind of statistics that most people learned in school. It's different. Here's an example of some of the differences. Every process or system produces output, and some of the output can be measured. We see the numbers, but we have a hard time making sense of them. So we need to have a way to make sense to understand how to react to these numbers. This slide shows some of the key concepts described by Dr. Schuhart and then by Dr. Deming. First of all, there are two types of variation. The variation comes from random causes, which was called common causes, which are also chance or unassignable causes. This is the kind of variation we saw in the bead factory. And the second type of variation is variation from what is called special or assignable causes. How we react to these types of variation makes a difference, and there are consequences to not reacting to the variation correctly. With common cause variation, it comes from the parts of the process or system and their interactions. It is not possible to trace the cause to one root cause. Here's a quote from Dr. Deming's 1986 book where he said, "People say our engineers never stop until they find the root cause behind every defect. which is totally wrong, and we're going to learn why that's wrong. Special cause variation comes from outside the process or system. It's something that is assignable. It does make sense to look for a root cause in these situations. Walter Shewhart discovered an approach to help understand this type of variation with the invention of the control chart. Here's a simple example of differences between common cause and special cause variation, and what I believe to be the consequences of not understanding the difference. Follow along on this simple example. Write the letter A 5 times in a row. Now switch hands with your non-dominant hand and write another letter A. The first 5 A's represent common causes of variation. There are slight variations produced by the system, its parts, and how the parts interact with each other. It does not make sense to ask why each letter A is different from the next. There will always be differences. Now, if you want to improve this system, what would be some ways to go about that? Perhaps you might work on a technique, or you could use a stencil or a pattern. No matter what you try, there will always be some variation in the letters. You will not be able to reduce the variation to 0. The 6th A represents special cause variation, something outside the system. In this situation, it does make sense to ask why the variation is different. So what, you may ask? Well, here's the so what. If you react incorrectly to the type of variation, you will make matters worse. There are consequences to not understanding variation, and that's why I consider this to be a guiding principle. The origin of this table comes from Dr. Deming's lectures that can be found in his 1993 book, The New Economics. In the columns, we see the 2 types of variation that can be present with any system or process. Common causes are random variation on the left column, and special cause, or as Dr. Shewhart described them, assignable in the right-hand column. In the rows, we see the 2 primarily choices we have when we notice variation in the output of a process. Row 1, we can react to each occurrence, search for the root cause, and remove it if it is undesirable. Or row 2, we can study and improve the system that produced the result and all of the results through the application of the PDSA cycle. Dr. Deming noted that most of the time systems and processes are producing common cause variation. He actually assigned a value of about 94% based on his experience over the years. I'll round this number of estimate over to 90% for common cause and 10% for special cause. Let's assume that's what the world gives us. When it comes to action, our predominant instinct under the prevailing style of management is to take action and do something. Don't just stand there. Shouldn't we be doing something? Many people feel the need to react, to be busy, and to take action. I'll assign 90% to that choice and 10% to the other choice. If you multiply the odds of the type of variation with the likelihood of the type of action taken, you begin to see the consequences for not understanding variation and the correct action to take. The primary culprit is seen in the upper left-hand quadrant, what Dr. Deming described as tampering. In this example, roughly 80% of the time we're making matters worse. You can see the percentages for the rest of the quadrants here. So through our best efforts and hard work and common sense, we actually are making the right choice only about 20% of the time. Although the likelihood of the wrong action in the lower right-hand quadrant is not high, it can still lead to wasted effort and actually makes matters worse. Anytime you see someone or some group change the entire system based on a one-time special cause occurrence, they are actually making matters worse. To illustrate the phenomenon of tampering in the upper left-hand quadrant, Dr. Deming used the funnel experiment, which he described in his lectures and in his book. You start with a simple funnel and a target on a tablecloth. Next, you need a marble that you drop into the funnel and you try to hit the target. With Rule 1, we let it drop and we mark the tablecloth wherever the marble drops. So we do this a number of times and we mark it wherever the marble lands and we get a rough circular pattern, as you see on this. Well, we're not happy with that. We're not hitting the target, so we want to make an improvement. So what we do is we adjust the funnel after each drop in the opposite direction of the last drop. The pattern you see now is actually getting worse. It's roughly 40% larger. So our efforts to make things better through Rule 2 actually make matters worse. So Dr. Deming explained Rule 3. We now devise this where we go back to the target each time before making that adjustment, and this time we should land right on the target. With this, we see that we're actually making a new kind of pattern, which starts to look like a swing from left to right or up and down, sort of like a bow tie pattern, each time swinging widely from out one side to the other. So defeated, we give up on hitting the target. We settle for making them all alike. We devise Rule 4, where we move the funnel to the last position where the marble dropped. We may not hit the target, but at least they will all be alike. With Rule 4, we see a pattern similar to this. It actually forms sort of a random walk, and eventually it'll go off of the tablecloth. Of all the rules, Rule 1, do nothing, turned out to be the best choice. And this is a good example of rushing in and doing something and try to fix something without fully understanding what's going on. In our example of the funnel, it seems simple enough, but this reflects real life examples, and here are some of the implications and consequences for Rule 2. And you can see all of these are examples, real life examples, where people are reacting to the variation. They think they're making things better, but they're actually making things worse. You see these kinds of examples every day. For instance, changing a company policy based upon the results of the latest attitude survey. Changing health benefits, price wars. Here's a healthcare example: when you adjust the insulin level based upon the last glucose level, or adjusting blood clotting medication with a similar medical test. Here's some examples of Rule 3 and Rule 4, real life examples where, without knowing what we're doing, we're actually making things worse. Rule 4 is interesting. You see this all of the time. A simple example is when workers are training workers in succession. The new worker comes on board. He's trained by the last one who came on board. He's now the expert, and he's going to train the next person. Whenever you have people getting together to try to share ideas without outside help, executives meeting to discuss what to do in this new economic age without guidance from profound knowledge, copying examples without any theory. A simple children's game where you play telephone, whispering some message to the kid next to you, and then so on, sitting around in a circle. And the initial message ends up to the final person, and it's totally different. So these are real life examples. It's funny when it's a child's game, but in real life it leads to disastrous consequences. The point here is that you're taking the time to try to study the system. That's what you need to be doing. So instead of adjusting the funnel, you need to improve it. So what are some examples about how you would improve this system? It could be simple, just as perhaps lowering the funnel, or getting a fuzzier tablecloth, or perhaps getting a metal marble and putting a magnet under the target. Some ideas are simple, and some will come at little cost or no cost. Some are going to be perhaps more costly. Let's put this into lean thinking terminology. This slide combines some of my thoughts with those of Jim Womack, former CEO of the Lean Enterprise Institute. I believe that when management doesn't understand variation and how to react to it, the consequences result in the production of Murray, overburden, or Murrah, unevenness. In his book, Gemba-Walks, Womack points out that Murray and Murrah are now the root causes of Muda, which is waste. I've heard a lot of talk about the identification of the 8 types of waste in work, but I don't hear anyone talking about getting to the root causes of the waste to begin with. I believe that if people looked upstream at the actions that management takes, they would often see that the misunderstanding of variation and how to react to it is actually producing more Muda than any of the workers could possibly handle. Here are some additional concepts and implications. When you have common cause variation only, improvement comes from studying and improving the system using the PDSA cycle. The incorrect action when you have common cause variation is to look for and try to explain the causes of the variation and adjust the process after each new occurrence. When there is evidence of a special cause, the correct action is to try to identify it and remove it if it produces unwanted results. Sometimes you have special causes that produce desired results. The incorrect action to take when you have special cause variation is to change the entire system. Now, you're going to occasionally make mistakes. It is not possible to be 100% certain of the type of variation you are dealing with. Plotting data using run and control charts helps you to make the right choice. And again, the most important application of all of these concepts is not when you have figures, but when you're dealing with people, some of the concepts that we've gone over. So when you have data, one of the first steps you can do is to plot the data. The chart at the top is a run chart, which can be done with a pencil and paper. You don't need to calculate any control limits. If you want to understand the limits of common cause variation, you can calculate control limits. There's easy formulas in Excel. They're all done automatically if you get the right program. And these can help you to understand, are you taking the right action or not? Here's some of the simple operational definitions for interpreting control charts. Any of the points within the control limits represent random variation, and there's no rational reason to explain any of the ups and downs. When you have one or more points outside the control limits, this represents a special cause, something to go after and try to understand. If you see 8 or more points on either side of the median or the midline, this represents a signal of a special cause, in other words, a shift up or a shift down. And if you see 6 points in a row that continually go up or go down without reversing the trend, this represents a special cause, which is called a trend. Here's a real-life work example. Our team's trying to look at ways to increase the social media activity. The table at the right shows the number of total followers per month. What can be derived by looking at tabular data like this? The answer is not much. A better way might be to look at the number of new followers per month. So we look at the table on the left. And what can we tell by looking at this data? Again, the answer is not much. For instance, does it make sense to ask why we had 60 in July and only 4 in October? Again, we have to put data into a run chart or a control chart. So the only way to know for sure is to put the data into a chart like this. So here's an example of the number of new followers per week that we're plotting, and you can see that this is random variation. You see that on average we had 14 one week and only 2 in another, and that would be tampering if we asked someone to explain why there was 14 one week and only 2 the other. The variation is due to the system and all of the parts of the system. So if we wanted to calculate the number of tweets that we're providing and we wanted to see more followers, the idea is if we had more tweets going out, we would be getting more followers. So we come up with a way of getting more people involved in this process. We create what we call a supermarket, where people put ideas into a holding pattern, and then we have a designated person that puts these out. And so we have more people that are involved with putting out the tweets. We can use this to determine whether our action is actually producing the desired results. Here's some of the results we've seen. We saw an increase in the number of tweets per week with our social media activity using the supermarket concept. And this did result in the number of followers that we had, and we saw some upward shifts. You can never be 100% certain that it was a one-to-one correlation, but we have a high degree of confidence that our supermarket system was helpful in producing an upward shift in the number of followers that we had, which was our desired result. We see the same thing with using this with LinkedIn, which is another social media platform. Again, we see an upward shift, and we do use this data to take a look at some of the posts that we generated during this time period to see if indeed this was due to some of the action that we had taken. Some of the ongoing use of this system, you can see the number of new Twitter followers per week and the number of new LinkedIn followers per week. The new system did produce an upward shift, and it does appear to be maintained, and there's no rational reason to ask anyone to explain the random ups and downs within the control limits. Here's some examples of some special cause variation where it does make sense to study this. It appears that some of this is due primarily to increased activity after our annual Lean Healthcare Transformation Summit. So this is a good example that if you wanted to have more LinkedIn followers or more Twitter followers, you would use opportunities such as those around those key events to try to generate some of that increased traffic. Here's another work example. We provide what we call Gemba visits, where we have people go to each other's facilities and go see the good work that is going on. At the end of the Gemba visit, we have the participants provide an overall ranking of how they felt the Gemba visit went, from a 1 to a 5. Each red dot on this, and each of these Gemba visits represents a response. The average for each of these is shown in the blue circle. Our current overall average is about 4.7 on a 1.5 scale. It's important to look at both the red dots and the average values in order to interpret this. With this chart, looking at some of the data, there's no rational basis to treat the last value of 4.5 as any different or to react. Improvement, as we've seen before, is going to come from continued work on the system, not asking why the last point was higher or lower. Here's some additional resources that you may find of interest. 2 webinars that I've recorded that have more detail, and the webinar that I referred to earlier with Mark Graben. Here's some books that I highly recommend. Books by Dr. Deming, a really great book by Don Wheeler, Understanding Variation, a terrific book by Peter Schultes, also one by John Hunter, and the one that I mentioned previously, the book on Thinking Fast and Slow, written by Daniel Kahneman, who was the 2002 Nobel Prize winner in economics. His specialty is actually in psychology. I hope you found this to be helpful. If you need to contact me, my information is shown at the bottom of this page. Thanks for listening.